All right, so we're going to look at 4.2 irrational numbers. And our first example is a sorting question. So we have to decide whether all of these numbers up here belong in either rational numbers or irrational number category. And they are kind of like opposites. And when we talked about rational numbers in grade 9, and it kind of boiled down to anything that could be wrote as a fraction. So if you can write a number as a fraction, then it is a rational number. And another way to look at that list is we can look at the real number system, which contains both rational and irrational numbers. As you can see, the rational number category contains a lot more of those common numbers that we see. So natural numbers, we think about maybe the whole numbers that are greater than 0. You get into the whole number system where you're including 0. You get into integers where you can now include negatives. But if you notice, in all three of these categories, there are no decimal numbers. Then if you start including decimal numbers, then you're into the rational number system. So if it's a repeating decimal, so for example 2/3 would be 0.3 repeating, that would count as a rational number. We could write 0.3 repeating as a fraction, so it will be rational. But we cannot write something like the square root of 2 as a fraction. And if we look and we actually get a decimal number for the square root of 2, you're going to see it's a number that goes on and on forever and ever and has no patterns to it, so there's no repetition. The most famous probably irrational number is pi. When we learned about that, we talked about goes on forever and ever and no patterns, but there's actually other irrational numbers as well. Another example is the negative square root of 5. Well, the square root of 5 is irrational, so putting a negative on it isn't changing it to rational either. So if you put the square root of 5, that's also a decimal number that goes on and on forever, and there are no patterns. So we cannot write that as a fraction. So here is our list, and I'm actually going to add another number to that, but I'm going to hold off on finding it. Okay, so 4. Well, that's a whole number. And we could write it as a fraction, multiple ways to write it as a fraction, so that is rational. And it's included in our whole number system. It's an integer, it's a natural number, it's all of those things. Negative 2/3. Well, it's wrote as a fraction, so it's definitely going to be in the rational number category. If you were to switch it to a decimal number, it has a repeating decimal. So if you want to think about it in terms of decimals, you can maybe think of like kind of a flow chart, where you're thinking, okay, is my decimal number ending? So like 3.2, 7.48. As long as it ends, then it's a rational number. Or if it's a repeating decimal, then it's a rational number. If you check your decimal number and it doesn't end, it doesn't repeat, there's no patterns, well then it's an irrational number. We have another fraction here, 1/2. We know that that's going to be a rational number. Pi. So pi goes on forever and ever. There is no patterns to it. So that is an irrational number. Let's pick out some other ones maybe that are a bit more obvious. So -6, we could write that as a decimal. We can write it as a fraction. It's rational. Square root of 9. Well, every time I see the square root of 9, I think 3. So that's a rational number because it would just be classified the exact same as 3. So if we're taking the square root of a perfect square, that's a rational number. The result would be a terminating decimal, which means we could write it as a fraction. All right, square root of 17. Square root of 17 is not a perfect square. 17 is not a perfect square, so the square root of that is actually going to be a non-repeating, non-terminating decimal number. Now our calculator doesn't go on forever and ever, but when we look at these first, 1, 2, 3, 4, 5, 6, 7, 8, 9 digits, we see there's no pattern there. And we can think about that in general as if we're taking the square root of any non-perfect square, it's going to be irrational. What else we got? Square root of negative 16. I think we're going to save that one at the end. Cube root of negative 8. So we put this one in here on purpose because it looks a little different than what we're used to. So if we have the cube root of a negative number, we're asking, is there a number that we can multiply by itself 3 times to get negative 8? Well, 2 times 2 times 2 is 8. And if we just put a negative in front of it, negative 2 times negative 2 would be positive 4. So if I just, negative 2 times negative 2 is positive 4 times negative 2 would give me that negative 8. So this is actually the exact same thing as negative 2, which means it is rational. If we look at the cube root of 9, 9 is not a perfect cube, so our perfect cubes would be 1, and then 2 times 2 times 2 is 8, and then the next perfect cube is actually going to be 27. So 3 cubed is 27. So this falls in between those. Since 9 is not a perfect cube, when you take the cube root of it, you get an irrational number. The cube root of 8/27. Well, this one here is going to be the same as the cube root of 8 divided by the cube root of 27. And when we write it like that, we can evaluate both the numerator and the denominator to see that it's actually 2/3. So if you put the cube root of 8/27 in your calculator, and you can do it a few different ways, but if I just say what's 8/27 as a decimal, and then I hit math, and you can already see that, so that's a term or a repeating decimal, which we would expect that it's either terminating or repeating because it's a fraction. Then we take the cube root of that number. What do we get? We get 0.6 repeating, which is what we expected. So that actually, although it looks kind of ugly, it is a rational number. We have 2 left. So 4 times the cube, 4 times the square root of 3. Cut. 4 times the square root of 3. Pause. No, Ava. Can't have this. Sorry. Thank you. You can't have it. Daddy's working. That is working. All right, 4 times the square root of 3. So 3 is not a perfect square. So when you take the square root of it, you get a non-terminating, non-repeating decimal number. And even if I multiply it by any number, it's not going to turn it into a perfect square unless you get pretty specific and, you know, maybe multiply it by the square root of 3. That would work, but whole number times the square root of a non-perfect number is going to be irrational. Finally, this one, there is no number, so this is the square root of negative 16. There's no number that we can multiply by itself and get a negative number. If you do a negative times a negative, it turns positive. If you're doing a positive times a positive, it's also positive. So this number actually, it is not a real number, so it's a trick question. It does not belong in any of those categories. It would be the opposite of a real number, which is an imaginary number, and you will look at that perhaps in the future.